So what's in a cold pack? This is thermochemistry in action. Well, looks like we have a salt. We have calcium ammonium nitrate, so that is the salt, and we have water in here. Let's open it up and see what makes this bad boy tick. We're supposed to squeeze this bag, but let's first take a look at what's inside. Looks like we have our water in there, and then we have the salt down below it. Here we are with the salt, and then the self-contained water bag. Apparently, when we squeeze the bag, we'll bust open this water, the salt will mix with the water, and we should get a significant temperature change. Let's take a look. So we have our calorimetry device, our Marquette calorimetry device. We have our salt from the cold pack. We have the water that was in the bag for the cold pack. I have a alcohol thermometer here, and there's my scissors. So let's open up that water. Let's dissolve this salt into the calorimetry device, Marquette calorimetry device, $9.99 on your Marquette website. And let's see what sort of temperature change we get. All right, so I measured out exactly 100 mils of water from the bag that was in the cold pack. I placed it here in my Marquette calorimetry device. And let's see if we can get a starting temperature here. This has been in here for a while. The thermometer has. So let's call this 21. We'll go with 21.2 degrees C. Okay. So 21.2 degrees C. Let's write that down. Then I took a cup and I added the ammonium nitrate, not all of it, but I added this much. So after I zeroed out the scale, I put in this much. So let's go with, we'll just call this 62.4 grams of the ammonium nitrate. Let's take a look and see what sort of temperature change we get here. So, here we go. Here we get it all. And let's get a gauge on the temperature. What do you know? We have a serious decrease in temperature. We were a little bit over 21 degrees, and now notice where we are. So we're under 5 degrees. Let's keep dissolving. So I have a solution here. The ammonium and the nitrate ionize completely. So ammonium ionizes to NH4 positive. The nitrate ionizes to NO3 minus. So now we have a strong electrolyte solution. Let's see where our temperature is. Notice we're getting close to 0. Serious decrease in temperature. Let's keep going. Well, it looks like we've stopped going down here, and it looks like we're a little bit over 0 degrees, and we're just gonna call that, 1.0 degrees C there. And there we go. You might ask, if this, could this get below 0? The answer is yes. This is not pure water. Solutions that have solute dissolved in solvent, with water being the solvent, those solutions will have a lower freezing point than the pure solvent. So water has a freezing point of 0 if it's pure water, but solutions, salt solutions, ammonium nitrate solution, which is what this is, will have a lower freezing point than pure water. Anyway, what you need to think about now is What is the system and what is the surroundings? In this situation where we're dissolving a salt in water, we're going to make the water, the aqueous environment, that is going to be the surroundings, and we're going to make those dissolving ions the system. So, what is the sign of the enthalpy change for this process? Next, you have all the information you need to determine the delta H, the enthalpy of this solution. So now you are going to determine the enthalpy change. Let's just consider the enthalpy equal to Q. So that's heat loss or gain. Remember, we often in this class will treat enthalpy and Q identically. Let's figure out the Q value, i.e. that is the enthalpy value of solution for this dissolving process. Q equals mc delta T. Let's have your answer in, let's go with kilojoules per gram. So kilojoules per gram for this salt. Let's do it.